Welcome to the geometry tutorial on proving triangles are congruent to go along with our journal 2.5.4 lesson. And let's take a look at this example right here. We have our given, M is the midpoint of AB. Now let's think about what that means. That means that AM is equal to MB. So I'm going to start when I'm proving a triangle by marking my given information and analyzing what it means. It also tells us that CMB is a right triangle, which is drawn for us, but we'll add that. Now the other part we need to know is, what are we trying to prove? And I just realized that wasn't typed in for us, so we'll type it here. We are trying to prove that triangle, and for sake of time, I'm going to write triangle AMC is congruent to triangle BMC. A couple things I want you to notice here, that A and B match, M and M match, and C matches C. When you're naming congruent triangles, it's really important. And you'll see that that's what you want to prove. You want to prove that A is equal to B, that C or ACM is equal to BCM, and that angle M is congruent to the other side of angle M. That's one of the things you want to learn when you're looking at congruent triangles. Well, let's start. The first thing you're going to do when you do any type of proof, if you're completely at a loss, where do I start? Just write one of the givens. M is the midpoint of AB. So we know that to be true, and since I'm typing, I will use that as well. Put that in there. Okay. Now, for the reason that, again, this is like the easy first step, you're going to say given. From there, we can list all of the givens here, or we could do more of a, that's actually supposed to be a 1, not a 2 right there. Let's see if it'll let me erase that. And I don't think it's going to let me erase that. Nope. Okay. What we want to do now is take a look at, well, what does that mean? Remember what we just marked? If M is the midpoint, that tells us that AM has to equal MB because it's a midpoint. So I'm going to go over here and say this is where the 2 belongs. Definition of midpoint. That's what it means to be a midpoint. Now we've got some sides. Now I want to step back a minute. We just started with what was the obvious, but let's think about this for a minute. We want to prove 2 triangles are congruent, and over here on the side, I want to create a little box of text. So far you've learned about proving triangles congruent. You've learned a few things. You could either prove all 3 sides, you could prove side, an angle, and a side, or you can prove angle, angle, side. And at some point you're going to learn about some right triangles, and well, we're not going to focus on that. We're going to look at the main 3 right here. Side, angle, side, 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 and angle, side, angle. Those are our 3 ways to prove triangles are congruent. So I've got sides and I've got an angle, right? The right angle. And so that's the one I'm going to focus on. So I'm going to really hone in on this one right here, a side, angle, side. That's the one I'm going to focus on. So I've got a side right there, AM and B. Now if you look closely, look at that next given, I've also got angles, because if this is a right angle, this one has to be a right angle also. And there's a couple things that could have been given. You could be given that well, let's write it first. I'm going to use the word triangle instead. I don't have a quick and easy symbol in this program for congruent or for a triangle. So triangle AMC, not what I wanted to say. Actually, what I wanted to say was that triangle CMB is a right triangle. Okay, and that was our given. If that's a right triangle, then we know that CM is perpendicular. Actually, I'll draw the perpendicular sign. To AB. And that would be definition of a right angle. If it's a right angle, then we know the line is perpendicular. If CM is perpendicular to AB, then we also know that the angle next to it is also a right angle. And there's a lot of ways to go about that. This is not the only way to say that angle let's see, AMC and angle CMB are right and congruent. Went a little over into my other line. Enter there. Okay. So because they're perpendicular lines, we know that those two angles are right and they're congruent. And that would be definition of perpendicular lines. You'll notice right now I'm using a lot of definitions. Okay, so now I'm going to mark with my pencil. I'm going to see if I can grab a different color. So now I've got, they'll let me use that. I've got this, oh, it didn't let me change it. And these are now congruent. So now I've got an angle and a side. Oh, look right here. Maybe it'll let me do this now. Look. Here's another side that's congruent to itself. So I'm going to go back to my text. Let's go back to my red color. Oops, it didn't let me go back to my red color. I'm just checking out this program for making videos, and so far I'm not really liking it. So CM equals CM, and that might seem like a silly statement to have to say, but we need to have in our proof all of the pieces. It's like stating the obvious. It's called the reflexive property because it's like you're looking in a mirror. If you think about it, CM equals CM. The equal sign is like a reflection. So that'll help you remember reflexive property. So now I've got my pieces. I'm going to double check. It's probably not going to like me going back to my pencil again. So I'm learning. This is a new program I just pulled from my toolbox, and I don't think I like it. But that's okay. So we've got, I'm going to have to use something else. It's just not letting me. Okay, here I'll try to point them. We've got sides, we've got angles, and we've got sides. So the very last step is to say that triangle AMC is congruent. Now pretend that's a congruent sign to triangle BMC. And then our reason why over here. Side, angle, side. So if you need, it helps to say, we'll just say side, angle, side, triangle, congruent theorem. And that would be done. We are done. We proved it. So you'd put a little QED right there. Now, one other possibility would be maybe it would go one more step and say, okay, now show that AB equals, show that AC equals BC. Maybe it wants you to go one more step. And so this is kind of a little extra. Once you know that two triangles are congruent, you can continue on to think about other things to be true. For example, now that you know those triangles are congruent, then you know that AC equals BC. And the reason for that, I'm going to write it all out, but I know the book talks about it in abbreviated form. So I will write it all out. It says corresponding, remember that's when you can pick them up and put them on top of each other, corresponding parts of congruent triangles are congruent. And almost everybody abbreviates it like this, C, P, C, T, C. So each of these letters stand for those words. Corresponding parts of congruent triangles are congruent. And that would be if you want to go to the next step. So now that you know the triangles are congruent, you can show that different pieces of the triangles are congruent. So you could also then even go to say one more thing. You could make one more deduction. Again, it's not part of our proof. I'm just showing you that one statement can lead to another statement of truth, kind of like being a detective. Now that you know those two pieces are equal, that also tells you that those two triangles are isosceles. So triangle AMC and triangle BMC are isosceles. And the reason why? Because that's the definition. The definition of being isosceles is that two sides are congruent. We've already shown the other side that CM was equal to CM. I didn't mean to say both of those are isosceles. Wrong thing. Got sidetracked. You can show that the big one, ABC. Let me go back and let me see if it'll let me erase that. Got ahead of myself. Okay. All right, and with that, I'm going to conclude kind of a little introduction for the journal.